Hi everyone, welcome to our webinar. We would like to inform you of the following in advance. To participate in the webinar, you will need either the web browser Microsoft Edge or Google Chrome, or you can participate via the GoToWebinar app. If you have any questions, you are welcome to ask them during the presentation in the questions window. You will find the questions window in the upper right corner of your GoToWebinar window. Your questions will be answered in a live Q&A after the presentation. This webinar will be recorded and the recording will be made available as an on-demand video. After the webinar, you will receive an email with a participation certificate. We will now start the presentation. Enjoy.
Hello everyone and welcome to today's webinar, Building Quality BIM Design. My name is Belin Haynes and I'm a Senior Product Marketing Expert at Graphisoft. I am joined today by Ward Turkiev from Solibri CheckPoint, and we're both excited to showcase the integration between ArchiCAD and Solibri for model checking and quality assurance. But first, I'd like to start with what we mean by quality assurance. Quality assurance in architectural projects is a systematic process designed to ensure that the design and the construction meet the required standards, regulations, and client expectations. It involves planning, monitoring, and improving the design activities throughout the project lifecycle. Quality assurance is crucial for maintaining a firm's reputation and ensuring client satisfaction. It can improve operational efficiency, save time, and reduce risks. And it helps identify areas for improvement for better outcomes over time. Ensuring quality assurance in architectural projects involves several best practices that span from comprehensive planning to third-party quality assurance. It needs transparent communication, investment in training the team, conducting regular audits, and incorporating digital solutions for data collection, analysis, and reporting. Today, we're going to go through ArchiCAD's native solutions as well as its connection to BIM quality assurance software, Solibri CheckPoint, to fulfill all these quality requirements before the BIM model is submitted. Multiple people working in one project can sometimes be difficult to manage depending on the complexity of the project, the number of users, or even the skill sets of these users. While this might sound scary, several tools within ArchiCAD, such as collision detection, graphic overrides, and issue management will help users achieve their office quality easily and have a healthy project that they can share with the others at the same time. The workflows are in constant loop throughout the project. Later on, Ward will go through the ArchiCAD Solibri CheckPoint workflow in detail and explain how the checks are performed in Solibri and then the models are exchanged between the platforms. And again, ArchiCAD's native issue management will come in handy when solving these problems. Okay, so let's start with our native solutions. The first one, and a great example, is the visual graphic overrides. With the help of this powerful tool, ArchiCAD users can create as many rules as they like and graphically override elements following these rules. Let's take the structural function checks, for example. The project might have been split between several users, and each user might have placed their own elements into their allocated areas without thinking about the data attached to these elements. The difference between the load-bearing and non-load-bearing elements is crucial for better understanding the project, especially for the structural engineer. So how do we make sure that this information is correct? Users can double-check and update this information with other tools, such as element schedules. But as architects, we might want to visually observe these where these problems occur. Graphic overrides help us achieve this. Whether it's a fire rating check, a simple layer classification check, graphic overrides help ArchiCAD users collaborate with a model that includes accurate data. Another useful tool for the quality assurance workflow is the integrated collision detection within ArchiCAD. This quick and easy-to-use tool helps ArchiCAD users check for collisions between two groups of elements, highlight them visually, and mark them up if necessary to be sent and assigned to the relevant teammate. If used externally, Users can run this tool between construction and MEP elements, for example, and then mark up the clashes, create the BCF files, and send these back to the engineers. The engineers then make their changes, send the updated file back to the architect, and happy days. Internally, within the design team, the collision detection tool can be useful when checking the headroom clearance for escape routes or staircases with defined tolerances, for example. So as you can see, this is a very useful tool to achieve your office quality without any headaches or effort. Well, we have identified the problems with the graphic overrides or collision detection. It is time to sort them out with ArchiCAD's issue management tool. Issue management in ArchiCAD is a robust feature designed to streamline the identification, tracking, and resolution of problems during the architectural design process. It consolidates all issues into one platform. Issues can be created by selecting problematic elements or discrepancies flagged during model checks. They can be highlighted, commented on, and assigned to a specific team member. They can even be exported or imported using BCF or PDF markup formats for interoperability with other applications that support OpenBIM workflows. This workflow is also crucial when collaborating with Solibri CheckPoint. We have explored our native tools, and now let's check out some other cool options. Our sister brand Solibri offers a seamless and a cloud-based model checking solution. Solibri CheckPoint seamlessly integrates into our workflow, saving us time, reducing errors, and making collaboration a breeze. It is easy to use, and the model checks are automated. It has seamless integration to several platforms, so everyone can work in their preferred BIM authoring tool. By integrating advanced model checking capabilities into existing workflows, Solibri CheckPoint simplifies the quality assurance while improving collaboration and project outcomes. For today's demonstration, we will use this medium-scale office building. Let's imagine I'm the lead architect with a team of 5 and regularly collaborating with my mechanical engineer. I will export an IFC model to be brought into Solibri CheckPoint, and let's see if any issues are going to come up before I send this to the client. So with that, I'd like to hand over to Ward, who will talk more about the improved BIM quality through automated model checking, streamlined workflows, and enhanced collaboration within Solibri CheckPoint. So over to you, Ward.
Hello, everyone. I would like to welcome you all to this part of the webinar. My name is Ward Turkiya, and I work as the Customer Success Manager for Solibri CheckPoint, where I help our users to integrate cloud-based model checking workflows into their BIM processes. In the beginning, let's have a bit of an overview about us, Solibri. So we've been at the forefront of BIM quality assurance for more than 25 years now. Our technology is trusted by industry leaders and has made a massive impact. So just last year alone, in 2024, Solibri users logged 14.6 million hours, identifying 3.2 billion issues before they could cause costly delays or errors, which translates to billions of dollars in both resources and time. And just recently, we've introduced Solibri CheckPoint, our browser-based model checker, which allow the users to have model checking experience in the cloud without the need to install anything on their local drives. Solibri CheckPoint comes in with an automated checking rule-based engine, allowing them to have multiple and different type of checks for their BIM models. There are different files that we support, including IFC, which can be authored from different BIM authoring tools, just like ArchiCAD, and also we allow for Revit model checking. There are different integrations that we have on Solibri CheckPoint, including Autodesk CDEs, just like BIM 360 and ACC, as well as Procore. There's a cloud-based flexibility, as there's no need to install anything on our local drive, and also we don't need high-performance machines in order to run Solibri CheckPoint. We have a flexible licensing system, as we offer floating license, allowing multiple users to use the tool, which enhances, of course, collaboration and efficiency. As for the interface, it's quite intuitive, I would say user-friendly. as we made the learning curve for Solibri CheckPoint much simpler than the other tools to make the model checking process much easier for BIM professionals. Solibri CheckPoint is a browser-based solution, allowing us to have 3D model coordination actions in the browser. So we can create different federated models. We can have some 3D actions that we can use, just like showing spaces, creating section boxes, show grids, and so on. As for the validation aspect, there are 3 main rules that we have on Solibri CheckPoint. The first one is for intersections. We have also another one for data validation, and the third one is for clearances. And that's for the graphical part. As for the data side of the model, we have a dedicated data viewer, allowing us to create customizable data sets for the BIM data that we have in the model. It helps us also in quantity takeoff, and we can do multi-level grouping for results where we get some results from the validation part. Regarding the reporting side, we can report in different ways. We can export to Excel, CSV, or we can create and track issues where we can also implement some BCF workflows. The added value for our users is that we offer instant and generic rule checks, which can be customized and can be used to recreate hundreds of rules, basically, to validate the BIM model. There is no cloud space limitation where we can create different federated models and model sets on Solibri CheckPoint, and we can keep them so we can use them later on. And we're working with 2 file formats, basically IFC and also Revit. As for the integration with other CDEs and other platforms, there's a live synchronization between our platform and the others, which enhances overall collaboration. And throughout the whole process, there are no plugins required or desktop solutions required in the process. So that was it for the theoretical part. And now I will move to the technical side, where I will share my screen and show you how we can validate some of the models that I got from ArchiCAD. So over here, I'm showing Solibri CheckPoint. As you can see, it runs fully in the browser. I personally use Microsoft Edge, but you can use Google Chrome, Firefox, or any other browser. At the moment, I don't have any projects active on Solibri CheckPoint. I only have the Playground project, which exists on all the CheckPoint accounts, which contains some example models that the users can have. So what I'm going to do, I'm going to create a new Solibri CheckPoint project, and then I'm going to upload one of the models that I've received from Pellin. We're going to validate that. We're going to conduct the rule checks on the model and see which results I can have from them. So from here, I'm going to create a new project. So this is the option. So I'm not going to integrate CheckPoint with any CDE because the file was sent to me to my laptop. So I'm going to just upload it directly to the project that I'm going to create. So from here, I'm going to give it a name. So it's going to be the S building. I think it's an office. So S building office. Next. And as you can see, it will open directly in the 3D viewer, and it has opened this project for me. So if I go back one step to the projects, you can see that I now have a new project that I can work with. From here, I can share this with my team members to work with me, and also I can invite external team members to collaborate also on this project. So the next step would be to go to this project and upload the model directly. So I'm going to add a model from here. I'm going to choose it, open, and it will start loading in the 3D viewer. So now the conversion has started for the IFC model. And on Solibri CheckPoint, we use different ways to convert the models depending on the type of the file. So now I'm working with an IFC file, which means that Solibri CheckPoint will convert it through our conversion system through IFC parser, which will make the file more compacted, I would say, and easier to use in the browser also, which will allow me to navigate freely through it. So the file that we see, or actually the one that we're going to see in a bit in the 3D viewer, is smaller in size than the original file. But of course, we don't scrape out any data throughout the conversion process, and we show everything. As long as you've included the properties, the parameters, all the BIM data that are required in the export initially, we will be able to read those in Solibri CheckPoint as well. Okay, so as you can see, now the model was added successfully to Solibri CheckPoint. And you can see now I have one version of this. So what I can do is that I can just click on the plus button, which will add it to the 3D viewer. And at the same time, it will be added to the second part, which is the model set builder. The model set builder is a feature which allows me to create my model set. And the model set is basically a federated model where we can add different models at the same time. So we can have one federated model in the 3D viewer. Okay, so this is the model that was sent to me by Pelin. What I'm going to do is that we can go to the data viewer just to have more insights on the type of data that we have in the model. So we're working with an IFC model. That's why we can see the IFC entity, the IFC GUID over here. And as you can see, we're running the default IFC data view. There are some different default data views which can be used from the left, depending on the type of file. We can run any of these ones. Also, you can just customize it from here. So the data viewer, basically, it shows you what you have in the 3D viewer, but in a more structured way. So if I click on any element in the data viewer, it will basically bring back this element also in the 3D viewer. And I can customize this table, so I can add more attributes to it. From here, I can edit the data view. If I want to add the model version, for instance, I can just add it, and it will be added as the last column over here. I can also ask CheckPoint to group all the elements that I have in the view. So I can group them by their IFC entity. And there you go. We have all these entities. But if I want to show only the IFC column, I can just click on isolate. And there you go. We will have the elements. There are some actions that I can use from the panel at the top, which has some 3D viewing actions that I can use throughout my process on CheckPoint. Okay, so let's reset the view and close the data viewer. From here, we can go to filters. So in this part here, you can see these 5 icons, which represent the 5 main steps that any user on CheckPoint will have to go through. So we started by getting our models. We grabbed them, whether from our local drive or we've imported them from a CDE. And then we went to the data viewer to have a more, I would say, more context on the BIM data. And the third step is to create filters. Now, the first 3 steps, we don't validate anything yet. We just have a better understanding of our model. And the 4th step, where we start actually validating using the rule checks. And the last step in the process is creating issues for the results that arise from the validation part. Okay, so what I'm going to do now is that I'm going to go to filters and create a filter for an architectural element. So let's choose the plasterboards in the model. So I'm going to add a filter from here. And then let's look for a property for the plasterboards. First, let me create a section. So let's rotate the section over here. So here we have these ceilings. There are plasterboards, I think. So element properties. Okay, so gypsum ceiling. That's the name of it. So we're going to click over here to add this as a filtering property. And then do a 3D preview. Yes, so it's working. So now we've selected all the gypsum ceilings. And also we should always save this filter, not to lose the data. So I'm going to copy this value and call it with the same name. I'm going to give it a different color. Blue one is good. And then save. So what I'm going to do next is that I'm going to use one of the rule checks that we have on CheckPoint. So we're going to go to the 4th step, rules. Then we're going to add a new one. And there you go. As I mentioned earlier, there are three main rules that we have on Solibri CheckPoint. The first one is clash check, designed for intersections. And then we have the property check for data validation. As for the last one, this is the free space check, which is for clearances. Each one of these rules has its own requirements, which we need to initially set. So if I go to the clash check, we need to add a base target, colliding target, which are basically filters. And then there's an additional requirement depending on the type of rule, which we need to add, just like tolerance for clash check, the property for the property check, and the dimensions for the geometry for the clearance on in the free space check. So at the base target, I'm going to add the filter that we've created for the ceilings, the plasterboards. As for the colliding target, let's create a new one, and we call it IFC. Let's look for the flow terminals. So we're going to add a property from here. We're going to search through the IFC entity equals to IFC flow terminal, which can refer to some electric elements and also some mechanical elements in the model. So I'm going to save. As for the name, we're going to call it gypsum ceiling versus flow terminals. Okay, we save it, and then I can run it from here to see the results. So after I run this check, you will see the results also reflected in the data viewer, and we can navigate through them. But for the element types that we have in the colliding target, which are the IFC flow terminals, we have different types. And you can see like different elements over here. And I think these ones are both coming from the electrical, like they are both electrical elements and also mechanical elements. So what I'm going to do, I'm going to group them all together based on their properties. So first we have the object type. So I'm going to group them according to specific, to two attributes basically. So here we're going to go look for object type. You can see we have this one, object type. And also I'm looking for the element type from the ArchiCAD properties. Yes, it has so element type over here. Okay. So I'm going to go to the data viewer and ask CheckPoint to add these two properties for the colliding elements. So the first one is object type. This is the first one. And then I'm going to add the element type from the ArchiCAD properties over here. There you go. We can save. So the object types, you can see light fixture, lamp, flow terminal, object. So I'm going to group them first by result. So now we have all the failed results in one group. Then I'm going to group them by the object type and also by the element type. So now if I go to the failed elements, we will see the clashes with flow terminals and also clashes with light fixtures. And within each one of them, we will see the element type. So in the flow terminals, we have the clashes with objects. So I can isolate them. And there you go. You will see only flow terminals. But if I go to the light fixtures, you'll see we have lamp and there's only one in object. So for the lamps, there you go. These are the clashes. And I think these are all approved, as these are only lighting fixtures, which can be below the plasterboard ceiling. As for this one, the object, if we take a look at it, okay, this is an interesting one. I don't think that this is a lighting fixture. Perhaps it's a cable tray or so, but definitely that this is something wrong. So as you can see, we can group the results that we have in the data viewer based on some specific attributes. And using the ArchiCAD properties, of course, this can be much easier. I've grouped them according to the element type from the ArchiCAD properties. And I think that this is a clash and this element needs to be moved to the top. So there are different ways to report this. We can, of course, export it to CSV, or we can create an Excel file, or we can create an issue with a screenshot and then have a workflow with BCF over there. But first, let's run the other checks, and then we can, and then I can show you how we can create the issues. Okay, so I'm going to reset the view and then reset the camera. Okay, so now we can move to the second rule that we have, which is the property check. So I can add a new rule from here. And then we can choose property check. So now we're going to validate. Let's look for a specific type of these elements. Okay, let's choose these doors. So this one. So we're going to validate if all these doors have the correct IFC entity. Not all the doors, just this specific type of door. So let me look for a type. So is there a type name for it? Because I want to select all these elements, we need to have a property that describes these elements properly so we can select. I think we can use the name perhaps. Here we have this name, but I'm not sure if it's for all the doors or only this one. Let's check. So over here, no, actually all the doors starts with D, perhaps. Okay, so I can select them based on this. So we're going to add a property from here, basically, which is from the attributes. I'm going to validate if they're assigned to the correct IFC entity. So for the property, IFC entity, and then it needs to be equal to IFC door. Now we need to select these elements. So I can just add from the filters, or I can create a new one. Let's create a new one and select all the doors, or let's say all the elements which starts with the letter D. So from here we go to name, and then begins with D. So we do 3D preview. And I think yes, so all the elements, regardless of their type, they have all the same or a similar naming convention, I would say, through the name property. So I'm going to save this. We're going to call it, we're going to call the whole rule as IFC entity for doors. So save, and then we can run it from here. Okay, so we got our results. You will see the ones which are not assigned to the correct IFC entity in red. And you can see that over here. The results will also be reflected in the data viewer. So now we can see the elements which have passed this check, and all of them, they have the IFC door, IFC entity. But if I group them by result, and then I go to the failed elements, you will see they're assigned to a different IFC entity, which is the IFC building element proxy. So this is for the property check. It can be used for classification codes, naming conventions, and so on. Any property that you have in your elements, as long as you're selecting the correct elements, then you can validate that. That's the second rule. As for the third rule, and that's the clearance check or the free space check, so I'm going to add a new one from here, and then we're going to choose the last rule we have. From here, we need to add different requirements. We need to add a target, basically, which I would say the elements that we're going to create the geometry for, and then we can make our required or disallowed elements, which should be or shouldn't be within the box. And of course, the dimensions of the box can also be adjusted from here. So we're going to create them for the doors, since we've already created a filter for doors. I'm going to add from filters, add, and then required. And as you can see, it will select all the doors and it will give them this green because the space is now created relative to the bounding box of the element, basically. It will take the shape of the bounding box. And then we can make the exceptions or the disallowed, the condition over here. So I'm going to create a new filter to select everything. We're just going to literally call it everything. So any element that is interfering with the free space or the clearance for the door should be retrieved as an issue. So from here, I'm going to add the property, and I'm going to select IFC entity, all the elements which have an IFC entity that is not equal to IFC space, because we know that we can have some spaces over here. So I'm going to select this. Okay, so any element within this area should be retrieved as a clash. Okay, so as for the dimensions, we can choose to make it from the front or the back of the door. First, let's choose from the front, and I want to have it 1 meter. So you can just remove the relative and then add 1 meter over here. So you can see this is the box that we're having. If there is any element within this area, it should be retrieved as a clash. We're going to call it free space for doors. We can do a 3D preview to make sure that everything is working well. Okay, so I think all of them has, except for this one. So here we have an issue. You can see there's an element, an obstacle in the free space. And that's only from the front of the door. Let's see if there is any clash from the back of these doors. You can do a 3D preview again. These ones over here. Okay, so in the toilet, there is less than 1 meter. It might be this is the requirement, so we can also adjust it from here. So actually it happens for all the toilets. And this one over here, let's remove the context. Okay, we have this element over here as well. Okay, so these are the results that we can have, but I'm mostly interested with the first one. So from the front of the element, we can save it, and then I can run it from here, which will show me the results basically. And there you go. We have only one element. So I can just group all the results together. Then you can see we have only one clash for this door, which is this one. Okay, so this is the issue that we're having. So there are different ways to report this and communicate it with our team members. So we can either export this result into Excel, CSV, or we can just create an issue straight from CheckPoint. I can click here to create the issue, which will take a screenshot for it. I can take multiple screenshots, and then we need to give it a name or a title. So free space for doors. So we can give it all the other information that are required to fix this one. So it's an active issue, stage. You can just put that's it. And then, of course, you can assign it to one of your team members. Now, this issue will be saved internally on CheckPoint, as you can see from the logo at the top. So now we're connected to the internal issue tracking system of Solibri CheckPoint, which allows us to collaborate with our team members on these issues. We can see which ones are active. And also we can see, we can have an option to export to BCF, or if we have more than one issue, we can export to BCF zip file. And this is how we can fix this issue basically now on ArchiCAD. I can export this to BCF. I can send it over to Pelen, and they can view the issue and fix it over there. There are some other workflows which require us to have an integrated workflow, and this can be done through a connection to an external issue provider. So these are the issue tracking systems that we're connected to. We're connected to ACC issues, BIM 360 issues, and also coordination issues in Procore. And of course, the connection is bidirectional, which means that we can update the issue from CheckPoint and see it instantly over there. So with this, I conclude my part of the webinar, and we can move to the next section.
Van S Architecten is een familiebedrijf uit Sliedrecht. Naast mijzelf zijn ook mijn broer en mijn zus actief in het bedrijf. We zijn een full-service architectenbureau en werken al geruime tijd met BIM. Ruime tijd geleden hebben wij in de markt gezocht naar welke producten er beschikbaar waren en gekeken wat het beste aansloot op onze werkwijze. De intuïtieve manier van werken, schaalbaarheid, maar ook de toepassing bij complexe projecten was voor ons erg belangrijk. Hier komt ArchiCAD als beste oplossing voor ons naar voren, waar wij al vele jaren fijn mee werken. De volgende stap voor ons was vanaf het moment dat ArchiCAD onze BIM-visie voldoende ondersteunde, was om de datakwaliteit te bewaken. Bij Van S is consistentie en datakwaliteit bij het ontwerpen van gebouwen onmisbaar. Het hebben van de juiste tools zorgt ervoor dat ons team zich kan richten op de meer strategische aspecten van het ontwerpproces, zonder hierbij afbreuk te doen aan de kwaliteit van de controles. Vanaf dat moment gingen we op zoek naar tools die ons hierbij kunnen ondersteunen en zo zijn we uitgekomen op Solibri CheckPoint. Het is helemaal fijn dat dit ook van een van de leveranciers afkomstig is. Om standaardisatie mogelijk te maken blijven we investeren in de uitbreiding van ons digitale ecosysteem. Daarbij geven we prioriteit aan cloud tools die kunnen integreren met ons bestaande proces. Vergelijk dit bijvoorbeeld met Microsoft SharePoint gebaseerde workflows. In de verdere transitie naar digitalisatie is het van belang voor ons als bedrijf om de ontwikkelingen voor te blijven. Om ons te kunnen blijven onderscheiden zijn we op zoek naar nieuwe en betere oplossingen die aan onze bedrijfsnormen voldoen. Daarom is het belangrijk om tools te gebruiken die aan de snel veranderende eisen kunnen voldoen en met ons mee kunnen bewegen. Een belangrijke aanleiding voor ons om dit te doen was omdat de markt hier steeds meer om vraagt. Kwaliteitscontroles in een ontwerpfase bepalen uiteindelijk de kwaliteit van een gebouw. Hoe beter de output, hoe beter het eindresultaat. Voor ons bood Solibri CheckPoint nieuwe functies met geïntegreerde workflows, die flexibel werken mogelijk maakt. Door ondersteuning van industriestandaarden zoals IFC, Revit, ILS, is Solibri CheckPoint toekomstbestendig voor ons bouw-ontwerpproces. Daarnaast stelt het onze teams in staat om onze klanten, partners en leveranciers real-time mee te laten kijken en feedback te geven tijdens het ontwerpproces. Wij zijn uitermate tevreden over het verloop van het proces. Solibri CheckPoint sluit goed aan bij onze visie op de toekomst en kijken hier dan ook met veel vertrouwen naar uit. Terwijl we dit uitrollen binnen onze teams, zorgt de gebruiksvriendelijke interface voor een soepele transitie, maar heeft het ook direct een tastbare impact op de productiviteit van ons team. Tot op heden zijn we tevreden over het verloop van het proces. Solibri CheckPoint sluit goed aan bij onze visie op de toekomst en we kijken hier dan ook met vertrouwen naar uit.
Well, this brings us to the end of the webinar. A reminder that it is recorded and you can watch the on-demand video at your convenience. If you're collaborating with an external stakeholder or simply just doing model quality checks internally and are interested in our solutions, scan the QR code on the left to learn more about ArchiCAD. To incorporate Solibri CheckPoint into your BIM workflows and for more information, please scan the QR code on the right. For participants, we also provide a free PDF of a 6-step workflow guide between ArchiCAD and Solibri CheckPoint. You can download it via the QR code on the screen. We do also have dedicated Learn and Community pages to improve your ArchiCAD skills and share your experiences with the other users. So, if you want to learn more about our quality assurance solutions, these QR codes on the screen will take you to our dedicated Graphisoft Learn and the community pages. So, thank you so much for your attention and for your time today. I hope you enjoyed today's webinar, and let's continue with our live Q&A session.